Welcome to a new video. In this video, we're going to talk about nested roots and varicles. Before continuing, let's take a look at the properties. We have two properties in order to solve such type of problems. In the first one, we have such a case that when there is an expression like a times mth root of b, in this case, we can send this a inside the roots like this. When a comes to the inside, then that a takes this m as an exponent, and then it comes inside. So it becomes a to the power of m times m in the root degree of m. In the second case, we see that there are, let's say, three roots like that, and the root degrees are a, b, c in order from outside to the inside. So in such type of questions, if there's no any number between the roots, then we multiply the degree roots like this, a times b times c, and that number becomes the root degree of the expression, and x stays inside as it is. Before solving this, let me write a couple examples about the properties. For example, let's say we have 2 square root of 3. This is equal to that 2 goes to inside like 2 squared, 2 to the power of 2 times 3. This expression becomes 2 squared is 4, 4 times 3 is 12. This number goes outside as 2, so we can do something in the reverse order as well. And as an example for the second case, for the second property, let's say we have square root of third root of 5. This number is equal to root degree of the first root is 2, of course, because if there is no any root degree, that means there is a hidden 2. So we need to multiply root degrees. 2 times 3 is 6. This is 6 as a root degree, and this is 5. And we all know that this number can be written as, at the same time, 5 to the power of 1 divided by 6. And now let's take a look at our first example. Again, the question is 3 square root of 2 is square root of y. In this case, what is the value of y? Well, we need to send this 3 to the inside of the root, and because in the root there is no number, that means there is hidden 2. So this is square root. We already know this. So once this 3 goes to inside, that 3 takes 2 as an exponent and then goes to inside of the root. So it becomes 3 square times 2 in the square root, which is equal to square root of y. On the left side, we have 3 square, which is 9. 9 times 2 is 18. Square root of 18 is square root of y. In this case, we can take the square of both sides. Can take the square of both sides. So 18 square in the root cancels. So it's going to be 18 is equal to y. Or in other words, before taking the square of both sides, we all know that there is root on the left, there is root on the right. So the insides should be the same as well. From here, we can easily see that y is also 18. And next question. In this question, we have 2 times third root of 4, which is equal to third root of 16 times x. So in this case, what is x? Well, again, let's send this to inside the root on the left, and let's see what happens. While going this to the inside of the root, it takes 3 as an exponent and then goes inside. So it's going to be 2 to the power of 3 times 4 on the left. So this is third root, which is equal to, on the right, we already have third root of 16x. So on the left, we have 2 squared, 2 cubed, which is 2 times 2 times 2, which is 8. So 8 times 4, the third root, which is equal to third root of 16x. On the left, we have 32. Third root of 32, which is equal to 16x. Both root degrees are same, so they are third root, so we can take the third degree of both sides, and then roots are gone, so it's gonna be 32 is equal to 16x as well. So here, because 16x is equal to 32, that means if you divide both sides by 16x, then you have x is 2. And let's continue with the next question. In this question, we have square root of 2 times third root of 2 times fourth root of 4 on the left, which is equal to 8 to the power of x. So in this case, what is the value of x? Well, we're gonna use the property 2 on the left in order to solve this question. So we're gonna send all numbers to the inside, okay, next to 4 on the left. So let's send this 2 to the right first, okay, while sending this 2 to the inside of third root. Then this 3 comes as an exponent to the 2, so it becomes something like this. Square root of third root of, okay, here we have 2 to the power of 3 times, there is 2, and then there is fourth root of 4, okay. These roots continue, and this is equal to 8 to the power of x. So here we have 2 to the power of 3 times 2 to the power of 1. Because bases are same, so we just add the powers. That means there is, here we have 2 to the power of 4, guys, okay? So the question becomes something like this. 2 to the power of 4, there is fourth root of 4, and there is third degree root, and there is another square root, which is equal to 8 is, you know that 8 can be written as 2 to the power of 3 to the power of x. And now we need to send this 2 to the power of 4 to very inside, okay? So it's gonna be 2 to the power of 4 to the power of 4, because that root degree, which is 4, comes to this number as an exponent, times there is already 4 inside, and we all know that 4 can be written as 2 to the power of 2. Now we have fourth degree roots, and we have another root here whose degree is 3, and we have another root whose degree is 2. And now, as we see, there is no any number between the roots. That means we can multiply the root degrees, okay? 3 times 4 is 12, 12 times 2 is 24. So this is equal to, the root degree is 24, and the number that is inside is 4 to the 2 to the power of 4 to the power of 4. If you take the power of the power, you need to multiply the powers. So that means 4 times 4 is 16. So it's going to be, this number is 2 to the power of 16. Times there is also 2 to the power of 2. Bases are same, so we just add the powers. So that means the number that is inside is 2 to the power of 18 is equal to, on the right we have, again, we are taking the power of the power, so we just multiply the powers. In other words, the right side is 2 to the power of 3 times x, which is 3x. So on the left, okay, 24th root of 2 to the power of 18 can be written as 2 to the power of 18 divided by 24, which is equal to 2 to the power of 3x. And we all know that in such conditions, if the bases are same, then the exponents should be same as well. I'm continuing to the left side. So from here, 18 divided by 24 should be equal to, guys, 3x. Here we have 1 in the denominator. If you apply the cross product, we're going to have 24 times 3x, which is 1 times 18, which is 18. If you divide both sides by 3 times 24, let me cut this part. So these are gone, x is alone on the left, x is equal to 18 can be divided by 6, and once you do it, okay, you have 3. Actually, you have 3 here, and 24 can be divided by 6, so you have 4 here, and that 3 goes with this one. So on the right, in the numerator part, we have 1 left over, and in the denominator part, we have 4 left over. So the right side is 1 divided by 4. That means x is equal to, guys, 1 divided by 4. Just let me write it here. X is 1 divided by 4 in our case. There is also some questions related to the infinity nested roots or radicals, but let's take a look at this subject in the next video. I hope you like it, guys. If you have any question, feel free to write them below. I'll try to answer them. Thank you for watching and hopefully see you in the next video.